Hello. So today we're going to talk about inequalities. So when you solve inequalities, it's the same steps as you would save an equation. But first of all, these are our inequality signs. So the first one is less than, well, the very first one says not equal to. But the ones that we're going to be using are the bottom four: less than or equal to, greater than or equal to. Okay, so this one right here says x is greater than or equal to 3. So that means we have an unknown number, and that unknown number is either greater than 3, which means it could be 4 or 5 or 6 or 6.5 or 7 1/4, or because there's a line here, it could be 3. So we go to 3 on a number line, we fill in the circle because x could be 3, or it could be any number to the right of 3 on a number line. This one says that x is less than or equal to 3. So this unknown number could be 3, or it could be any number less than 3. So it could be 2, it could be 1/2, it could be -5, it could be negative 0.75. So we go to the number line, we find the number 3, we fill in the circle because x could be 3, or our arrow points to the left because it could be any number to the left of 3 on the number line. This one says x is greater than 3. Our unknown number is greater than 3. That means that x isn't 3, but it could be any number greater than 3, like 3.1 or 3.15 or 3.7 or 5 or 10. So when we go to 3 on the number line, we put a circle but leave it open, meaning that x isn't 3, but it could be any number to the right of 3 on the number line. And that's similar to the last one. X is less than 3. We find 3 on the number line. We put an open circle and we point to the left because x could be 2 or 0 or -1 or -2 or -4, so on and so forth. Okay, so that's how you read these inequalities and you graph them. So just like if this first one were an equation, the way we would solve for x is we would do the opposite of multiplying by 2, which is dividing by 2. We would bring down x, we would bring down our equal sign, and we would bring down 5. 10 divided by 2 is 5. The only difference is, instead of bringing down our equal sign, we're going to bring down our inequality. So this says x is greater than or equal to 5. X could be any number 5 or higher. So when we go to our number line, we're going to put that number in the middle. So 5, 6, 7, that would be 3, that would be 1, this would be 9. We're going to find 5. We're going to do a closed circle because it says x could be 5, or could be any number to the right of 5 on the number line. Now look at that inequality sign. It's pointing that way, correct? Doesn't the end of the arrow also point that way? So as long as your variable is written first or to the left of the inequality sign, this symbol will look like your arrow. So that's a good way to remember which way your arrow should be pointing. It should look like your inequality sign as long as your variable is written first. All right, so let's look at this problem. If this were an equation, and I told you to solve the equation, we want x by itself. So how do you get rid of a positive 5? You would subtract 5 from both sides of the equal sign. So that's gone. Gone. We'd bring down our x, we'd bring down our equal sign, and 3 minus 5 is -2. So this time, instead of equals, we bring down our less than sign. So now I want -2 about the middle of my number line. This would be 0. This would be -4, so on and so forth. I'm going to do an open circle because it doesn't say x is equal to -2, but it's going to be less than -2. So if this was an arrow, it would be pointing to the left. So x could be any number to the left of -2 on the number line. All right, let's do the next one. We want x by itself. So the first thing we're going to do is get rid of -3. So the opposite of -3 is +3. So we bring that stuff down. This is gone. We bring down x squared. We bring down our less than or equal to sign. And 7 plus 3 is 10. So now the opposite of times 2 is divided by 2, divided by 2. X is less than or equal to 5. X is less than or equal to 5. Here's 5 on my number line. It's a closed circle because of this or equal to sign, and my arrow points to the left, pointing to the left. So that's the third one. All right, you guys try the next 3, pause the video, try to solve them and graph them, and then come back and check your answers. All right, now this says 1/3 times x. So we've talked about these before. If we want 1/3 times a number to be equal to 1, you would multiply it by its reciprocal. So when you have that you are multiplying by a fraction, to cancel out that fraction, you are going to multiply by the reciprocal. So we're going to multiply this side by 3 over 1, and we're going to multiply this side by 3 over 1. So 3 over 1 times 1/3 is 1, and 1 times x is x. We bring down our greater than sign, and 1 times 3 is 3. So we want our 3 in the middle of the number line. We're going to fill in, no, we're not. We're going to have an open circle because it doesn't have an or equal to sign, and our arrow points to the right. Okay, so how'd you guys do? Did you get it? All right, let's look at the third or the next one. So we want to solve for x. So how do we get rid of positive 7? The only way to get rid of a positive 7 is to subtract 7. So we're going to subtract 7 from both sides. So 2 minus 7 is -5. Bring down our inequality. This is gone, and we bring down our x. Now, remember what I said earlier about your arrow will look like your inequality sign if your variable is written first. Well, here it's not written first. Let me rewrite it over here so we can see it better. All right. So my arrow would not be pointing to the left. It would actually be pointing to the right because the variable is not written first. So basically, I want to always turn this around so that my variable is written first. Now, if you flip these numbers, you have to flip that sign. So see how the big part of that, whatever that thing is, the inequality, the big part is pointing to the x. Well, if you write the x first, the big part, the open part still has to be pointing to the x, and the point has to be pointing to the -5. So be careful. Don't just try to rearrange the letters or numbers and not flip the sign. So now I see that my variable is written first. There's my -5. I'm going to fill it in because of that or equal to sign. And now my arrow looks like my inequality symbol, which is pointing to the right. All right, and then the last one, I want to get rid of 2 things now. I want to get rid of -4. The only way to get rid of -4 is +4. I'm going to bring down 3x. I'm going to bring down my inequality sign, and -13 plus 4 is -9. And so now I have 3x is less than or equal to -9. So the opposite of multiplying by 3, I'm going to divide by 3. Gone. So x is less than or equal to -3. All right, so here's my inequality. No, here is my -3. This would be -1. This would be -5. I would fill in that circle, and my arrow points to the left, just like my inequality sign. All right, what do you guys think? You got to do these on your own, guys. You can't just watch me do these. You have to print these papers off. You have to do these problems with me. You can't learn anything just by watching me do them. Okay, so make sure you're doing these. You're taking notes. Make sure you keep up with a math notebook. You need to, just like if you were coming in building to school. All right, so let's look at some short word problems. It says you can have, let's say your mom says, you can have more candy if you've eaten less than 10 pieces. So what does she mean? Can I have candy if I've eaten 10 pieces? No, 10 is not less than 10. What if you ate 9 pieces? Can you have more candy? Yes. How about 8? Yes. How about 10? Nope. 11? No. 7? Yes. All right. So basically, the number of candy, we can have more candy if the number of candy we've already eaten is less than 10, right? So in a number line, here would be 10, here would be 9, here would be 11. If I've eaten not 10, but less than 10. Okay. And then one day you go up to your mom and say, Mom, I need to buy a video game that is more than $25. How much could the video game cost? Could it be $25? No, it's more than 25. Could it be 26? Yep. Could it be 30? Yes. Could it be 20? Nope. So that video game is going to be more than $25, not equal to $25, but any number more than $25. So our arrow would point to the right. All right, let's say you're telling your mom, Mom, I'm going to the mall. Can I have at least $25, please? What does that mean? How much money do you want? It means you want $25 or more. That's what at least means. It means the smallest amount I'll take is 25, but really I want more than that, right? So the amount of money I'm asking for Mom is greater than or equal to $25, not less than. If I say at least 25, if Mom gives me $20, I'm not happy. So think about these in your own, scenario, and we all understand money. So if you can relate anything to money, you can probably understand it more. Your mom says, yes, you can go to the mall, but you can have no more than $25. What does that mean? That means that 25 is the maximum. So the amount of money your mom's going to give you is either less than or equal to $25, right? You're like, Mom, can I have at least 25? She said, well, you can have no more than 25. So it sounds like you're getting $25. So those words, if in word problems, you need to know what inequality to use. Less than goes with the sign, more than goes with that sign. At least is greater than or equal to. No more than means less than or equal to. All right, so take a look at how Eric's scenario, so obviously I left something out of this. So Eric gets paid $25 and then he earns 10 cents for each snow cone. He needs at least $52.70. So how much money does Eric need? Well, it depends on how many snow cones, or let's say, so really what X is going to represent is the number of snow cones Eric needs to sell. Because we know how much he already has. We know how much the snow cones are. We know how much money he needs. What we don't know is the number of snow cones Eric needs to sell. Do you understand? If he's going to make money by selling snow cones. Well, he already has $25. Plus, he earns 10 cents per snow cone. So how many snow cones does he need? Well, if he needs at least $52.70, what does that mean? He needs greater than or equal to $52.70. So how many snow cones does he need to sell? Well, let's find out. The first thing we're going to do is get rid of positive 25 by subtracting 25 from both sides. So this is gone. We bring down 0.10 cents times the number of snow cones. We bring down our inequality sign. We subtract. We get $27.70. He still needs at least $27.70. So now what's the opposite of multiplying by 0.10? We're going to divide by 10 cents. We're going to divide by 10 cents. So 0.10 times divided by 0.10 is 1, and 1 times x is x. Bring down our inequality sign. So now that's a lot of snow cones, you guys. 27.7 divided by 10 cents is 277 snow cones. Eric, you best to get busy, buddy. So if Eric needs at least $52.70 and he's only making 10 cents per snow cone, he's got to sell 277 snow cones. So the number of snow cones Eric has to sell is 277 or more, right? So he could sell that many and he'd have exactly 52.70, or he needs to sell more than that. All right, let's see what else we got. Millie has $78. On her trip to the state fair, she wants to buy a snack for $8 and buy admission tickets for her friends at $9 each. Write and solve an inequality to model how many friends she can take to the fair. So X is going to equal number of friends. So if you have $78, can you spend $78? Can you spend more than $78? Can you spend less than $78? Yes. So the amount of money she spends has to be less than, or it could be equal to how much money she has, right? So let's see what this side is going to say. She is going to buy a snack for herself for $8, plus she has to buy tickets $9 each. So $9 for her friends for one ticket. We got to see how many tickets she can buy tickets for. All right, so first thing we're going to do is find out X is represented the net number of friends. So first thing she's going to do, we're going to subtract her $8. And really, you know what? I'm thinking about it. If she's going to get into the fair, I know this is kind of a tricky part, but if she's going to get into the fair, doesn't she need to buy her own self a ticket? So you know what? I'm going to add that to this $8. She's going to buy herself a ticket. She's going to buy herself a snack. Plus, she's buying tickets for how many friends that are $9 each? Well, I'm going to go ahead and say she has to buy her ticket too. So she's going to spend $17 on her own ticket and her snack. Plus, now she can bring some more friends in, right? Does that make sense? I don't want to make it too technical, but that would make sense. She has to get in herself, or maybe she already had a ticket. Let's say she didn't have a ticket and she needs to buy herself a ticket, buy herself a snack, and now we can see how many friends she can get in. So we're going to subtract out of how much money she had, her ticket and her snack. That leaves $61 left. And now, if she's buying tickets that are $9 each, well, 61 divided by 9 is 6.7. So can she buy 6.7 friends a ticket? 6.7? No, that doesn't make sense. That you don't have part of a person. Does she have enough money to buy 7 tickets besides herself? No, she doesn't have enough. So she can bring 6 of her friends or less, because this says or less than. She can buy tickets for 6 people or less. Okay, that makes sense? I hope it does. All right, let's look at the next problem. Oh, and we didn't graph that, but you guys know hopefully what it means to be graphed. All right, solve the inequality and graph the solution on the numbered line. So first thing we're going to do is get rid of plus 3. So first thing we're going to do is subtract 3 from both sides. We bring down our 1/3 x. Our 3's are gone. We bring down our inequality, and 2 minus 3 is -1. All right, here's a variable multiplied by a fraction again. What did we say? How do you cancel out multiplying by a fraction? Or we're going to multiply it by its reciprocal. We're going to multiply this by 3/1 and this by 3/1, which is just 3, isn't it? So this times this is 1. So x is greater than or equal to -1 times 3 is -3. -3. So we're going to find -3. This would be -1. This would be -5. So we have a closed circle because it says or equal to, and our arrow points to the right. Okie doke. All right. All right, now the one thing you do have to remember when you're using inequalities is if you multiply or divide by a negative number, you should say multiply or divide by a negative number, you have to flip your sign every time, every single time. Only if you multiply or divide by a negative number, not if you have an answer that's negative. That doesn't mean that. If you multiply or divide by a negative number, you have to flip your sign. So first thing we're going to do is cancel out +3 by subtracting 3. So we're going to get rid of this. We're going to bring down -2x. We bring down our inequality, and 13 minus 3 is 10. And now how do you get rid of times -2? You're going to divide by -2. Now we're dividing by a negative number across an inequality, which means we have to flip the inequality. So 10 divided by -2 is -5. All right, so you have to remember that. So write that down. When you multiply or divide by a negative number using an inequality, you have to flip that inequality sign. If you don't, it's wrong. All right, here, what we're going to do is get rid of this +3. The only way to get rid of a +3 is to subtract 3. So 3 minus 3 is nothing. We bring down our -x squared, or what am I saying? -3 times x. We bring down our inequality. 9 minus 3 is 6. How do you get rid of times -3? You divide by -3. We're dividing by a negative, which means we're going to flip our inequality sign. And 6 divided by -3 is -2. So here's our -2. Here would be 0. This would be -4. We fill in that circle, closed circle, and it points to the left. All right, the third one, to get rid of times a fraction, you multiply it by its reciprocal. The reciprocal of -1/2 is -2/1. We're not changing the sign, we're doing the opposite. We're getting rid of the number. So if we multiply this side by -2, we got to multiply this side by -2. So -2 times -1 is 1, and 1 times x is x. We're multiplying by a negative number, so we're going to flip our sign. And 4 times -2 is -8. And if we're going to graph that, oh shoot, what did I put? I had x is greater than or equal to -8. -8. I'm having a hard time with this one, guys. -8, -10, -6. So there's our closed circle, and it's pointing to the left. Okie dokie. All right, let's look at this one. Jamie has $12.75. Can you spend that much money if you have it? Yes. Can you spend more than that? No. Can you spend less than that? You can. You don't have to spend 100% of it. Jamie has $12.75 and plans to purchase snow cones for all of his friends for $1.25 each. If he needs to save at least $8.75 to pay for lunch, how many snow cones can we buy? Now, we're not worried about Jamie buying his own snow cone. We're not worried about that. So if Jamie has this much money, the amount of money he can spend can be equal to or less than or equal to $12.75. And X is going to represent the number of snow cones he can buy his friends. All right, if he has this much money, he has to make sure he's going to spend $8.75 for lunch plus $1.25 times the number of snow cones he buys, right? So we want to know how many snow cones he can buy. So the first thing we're going to do is subtract out his lunch money from how much he has, because he wants to make sure he can buy himself some lunch. So this is gone. We bring down 1.25 times x. We bring down our inequality sign. If he had $12.75 and needs $8.75, he has $4 left. So now it says 125 times x. So what's the opposite of multiplying by 125? Dividing by 125. So we're going to divide both sides by 125. We don't flip that inequality sign. We're just dividing by a positive number, but 4 divided by 1.25 is 3.2. Well, this represents snow cones. If he walks up to the lady and says, can I have 2/10 or 0.2 of a snow cone? What's she going to say? You either got to buy a whole one or not one. So he can buy 3 snow cones or less. X equals less than or equal to 3. All righty. Oh, and there's my number line. All right, now you guys have some problems to do. So here's an example of one. So the first thing you're going to want to do is you're going to have to solve these inequalities, because what is graphed up here? X, the unknown part, is either equal to -1, or my arrow goes like that, doesn't it? So this is X is less than or equal to -1. So one of these has to say that. One of these has to say that. Well, look at these bottom two. They don't have the or equal to, and this is filled in. So I'm automatically going to eliminate C and D because they don't have the right sign. So I'm going to solve the top, the letter A and letter B, and see which one will give me this answer right here. All right, so first thing I'm going to do is the first thing I'm going to do is subtract 4 from both sides. So I have 3x is less than or equal to 1 minus 4 is -3. I forgot that sign. And then 3 times x, I'm going to divide by 3, and I'm not flipping my sign because I'm dividing by a positive number, but x is less than or equal to -1. So that's it, the very first one. So even if it was the second one, I would save myself time by eliminating 2 answers by figuring out what my inequality is right at the beginning. Okay. All right, let's get rid of this stuff. It says it costs $10 to attend a golf clinic. Bucket of golf balls costs $2 each. Write an inequality that shows how many buckets of golf balls Jack could buy if he has $22. Well, if he has $22, the amount of money he can spend is either going to be less than or equal to $22. You can spend $22 or less if that's how much money you have. It's going to cost him $10 to get in, plus 2 times the number of buckets he's going to buy. So the question is, how many buckets? X equals the number of buckets. Number of buckets. So we're going to get rid of the 10 first. So we bring down 2x is less than or equal to 12. And then when we divide both sides by 2, we see that Jack can buy either 6. The number of buckets can be equal to 6. He could buy 6 buckets or less than 6, right? Because he can spend less than $22 if that's how much money he has. All right, so what about this one? We want to solve for x. So the first thing we're going to do is get rid of plus 50. So we're going to subtract 50. We're not flipping our inequality. You're allowed to subtract a number and not, it's only when you multiply or divide by a negative number, right? So we have 3x is less than or equal to -45. And then the opposite of times +3, we're going to divide by +3. So x is less than or equal to -15. All right, so -15 goes in the middle. This will be -13, this will be -17. We're going to fill that in and we're going to point to the left, just like our inequality sign. All right, let's try this one. We want to solve for x, so we're going to get rid of plus 11 by subtracting 11. So we're going to bring down -4x, bring down our inequality sign. 3 minus 11 is -8. Now what's the opposite of multiplying by -4? We're going to divide by -4. What happens when you divide or multiply by a negative number? You flip your sign, and -8 divided by -4 is +2. So 2 is right in the center of our inequality. Fill it in, point it to the right. Oh, and that's it. All right, you guys, that's a lot, but hopefully you printed those out, you did those with me, and now you have some good examples to look at when you do your own. All right, you guys have a good week, and if you need my help, let me know. See ya.